folks, welcome to our last free response. This time we're going to graph an exponential function. And I can see it's exponential because the variable is up here in the exponent. Right? I've got a base of 1/3, so I've got some exponential decay. And I say decay because this number is less than 1. So let's just start picking these apart. All right, traits, domain. Okay. So I want to look, do I have any fractions, radicals, or logarithms? And I don't have a fraction where the variable is in the fraction, right? I have 1/3 here as a constant, and that denominator is never 0. So when I say something like I have no fractions, radicals, or logarithms, let me make sure you can see the word or logarithms. I'll just write it down here. With a happy face, you might say, well, Miss A, you do have a fraction. It's here. Yeah, but there's no variable in that 1/3. Those are just numbers, so that denominator is never 0. So that tells me my domain is all real numbers. And we're going to write that up in interval notation as negative infinity to infinity. Okay. All right. Let's see if we can't find some intercepts, x and y intercepts. So if I ever want to find an x-intercept, you're going to let y equal 0. All right, or in this case, f of x equals 0. So I want to see when is 1/3 to the x minus 1 equal to 0. And because I have an exponential equation, if I want to get that variable out of the exponent, I'm going to need to log both sides. And I tend to use ln, so I'm going to do ln of 1/3 to the x minus 1 equals ln of 0. Right? And through properties of logarithms, I could move this down and solve for x. But the thing is, ln of 0 does not exist. Right? We're not allowed to take the logarithm of 0 or a negative number. If I tried to do it on my calculator, you'll see even my calculator says there's an error. So since this does not exist, there are no x-intercepts. Totally fine. I'm just going to write none here and be happy with it. All right. Now, for y-intercepts, if I want to find a y-intercept, I'm going to let x equal 0. You always let the opposite letter 0 out. So let's do y-intercept. And I will have a y-intercept because 0 is in my domain. So let's figure out what f of 0 is equal to. So that's going to be 1/3 to the 0 minus 1. Okay, 0 minus 1 is negative 1. So I have 1/3 to the negative 1. The negative exponent, it's that traveling exponent. So anything in a numerator moves to a denominator. Anything in a denominator moves back up to a numerator. So basically the reciprocal of 1/3 is 3. 3 to the 1 is 3. So that becomes my y-intercept, 0, 3. Okay. All right, so I'm going to scooch this up and we're going to start to talk about end behavior. All right, now end behavior on exponential functions. Again, your baseline exponential function, right? We know it starts here and heads up, right? There's an asymptote and then an arrow. So usually with exponential functions, there's a combo of an asymptote on one side and an arrow on the other. And we just have to evaluate which side is which and what those equations for that horizontal asymptote might be. So let me scooch this up just a bit so we have some space. Okay. All right, so for end behavior, let's look at it this way. Let's break it apart left side and right side. So we're going to let x go to negative infinity, meaning I'm going to move left on my graph. All right, if x is going to negative infinity, I want us to think about where is f of x headed, right? So if I think about this as 1/3 to the negative infinity minus 1. And then we're going to just start collapsing some things. So negative infinity minus 1 is essentially negative infinity, all right? It's that universal, that infinity just kind of sucks things into it. It's like a black hole, a vortex. So this is going to be 1/3 to the negative infinity. Again, we know that negative exponent, it reciprocates, right? It's the traveling exponent. Numbers or terms in a numerator go to a denominator, denominator to numerator, or really you can think of it as the reciprocal. Reciprocal of 1/3 is 3, so this will become 3 to the infinity. 3 to the infinity is infinity. This is still a huge number. So what that's saying is, as x goes left, right? As x goes to negative infinity, your y values go up. So I have left and up. That's what that is saying. Left from x going to negative infinity, up from y going to positive infinity. So I have left and up. So when I go to do my end behavior, can we still see this? Yeah. I'm going to have left and up, which probably means on the other side, I'm going to have the horizontal asymptote, but let's find out. All right, so now let's go to the right end. Let's go x to positive infinity and see where our y values go. Where does f of x go? So we're going to have f of x would equal 1/3 to the infinity minus 1. Right? All right. Infinity minus 1 is essentially infinity, so I have 1/3 to the infinity, right? And I can distribute that exponent, so you can think of this as 1 to the infinity over 3 to the infinity. Right? 1 to the infinity is just 1. 3 to the infinity is a huge number. 3 to the infinity is gigantic. Right? It's a very, very large number. Essentially, it's still just infinity. And 1 over a really, really, really large number is essentially 0. Right? Think of it as, and I always say, like, if I think of 1 over a million, because a million is like a really, really large number. And if I gave you 1 over $1 million, you would not be excited because I basically gave you $0. All right, so let's think about what this means in terms of end behavior. All right, if x is going to infinity, that means we're going right and the y values are going to 0. So they're going to this horizontal asymptote of y equals 0 on the right side of our graph. So I'm gonna say here that we have a horizontal asymptote, y equals 0, but this is just on the right. All right, and I'll go figure out what the range is in a moment. Let me go start to write this up. Now, just taking a look, anytime you have exponential growth or decay, I'm gonna scale these a little bit larger. I'll make these each worth 10. Let's see, our y-intercept is at 3, 0, 1, 2, 3. I had left end up. Let me scooch this so we can see it all. And I had right end with a horizontal asymptote of y equals 0. So I'm going to go write that in for us, so we can see it. Yeah. Okay, so we had our horizontal asymptote, y equals 0 on the right. Okay. Now I want some other points to kind of guide me. So let me go ahead. Let's pull up our calculator. Oh, you can still see I had the domain issue from our last problem. So I'm gonna go ahead and do 1/3. I'm gonna raise that to the x minus 1. I'm gonna protect that with parentheses. Now I'm gonna hit zoom 6 because I don't quite remember what my window was before. So let's see, I do see some exponential decay in there. That's good. Let me get some other ordered pairs as just a guide. So it looks like -1, 9. So -1, 9. All right, 0, 3, 1, 1. That's a good one to have. And then 2, 1/3. It's going to get real small real fast. So with that, I can start to sketch my graph. And then you can see the left end is up. That matches the algebra I did for end behavior. And there we go. So my graph goes from a y value of 0. It doesn't hit, it gets asymptotically close, but it doesn't hit 0, right? So I'm gonna have a parentheses all the way up to infinity. Let me scooch this down just so we can fill in our range. So my last entry is gonna be 0 to infinity. All right, thanks so much everyone. Bye.